In this video, I'm going to look at how you make use of flowcharts. So last time I covered a video on how to write pseudocode. So this is like a build up on that. So if you didn't have a chance to watch that, or if you're not familiar with how to write pseudocode, you do to get yourself familiar with that, or watch the previous video on pseudocode. As for now, we get started on flowcharts. So flowcharts, the idea is to represent the same thing that we are doing in pseudocode. It's like we are saying in pseudocode, we're able to represent steps that will be taken to solve a problem in form of statements. We saw something like this, where you say, something like this, where you can say, let someone enter the radius. If the radius is less than 0, then display radius is invalid, or display restart and enter correct value. Else, or if not, meaning if the radius is not less than 0, then in this case you say find the pi, assign the value of pi to 3.142, and then assign the value of area to pi times the radius. So all what we have here is, this is an example of pseudocode. Now, instead of writing things like this, we are saying, can we have a different way of representing the same thing? And that is what we do by making use of flowcharts. So the basic principle that you need to take note of here is that in flowcharts, there is a use of shapes. Okay, so shapes are used to represent different operations that are going to be done in a specific activity. Now, each step in a process, each step of a process is represented by means of a shape. So there's a shape that is standing for everything. So what this entails us is that if we're looking at some kind of pseudocode like this, we are saying that there should be a shape to represent this process here. It should also be a shape to represent this condition, and obviously there will be a shape to represent this, as well as this. So each of these statements here are going to be like a shape. So this will also be a shape on its own, and this will also be a shape, and then this one also be a shape on its own. So every step is going to have its own, every step or every activity in the pseudocode is going to have a corresponding step. Okay, that's a point that we're trying to make on bullet point number 2 here. Now, what do we put inside the shape? Inside the shape, there is going to be some form of text that more like gives you an idea of what is being done here. What is that shape about? What is happening in that? Okay, so there will be some kind of a text, which will show you what's really happening in that. But despite putting in something in the shape to show what's happening, we don't just use any kind of shape. So flowcharts has specific types of shapes that are used for representing these processes. So there are specific shapes. For example, there is going to be a shape that looks like this. Okay. Sorry about this. So here is this. Okay. So if a process, sorry, I don't know why I'm doing this like this. Yeah. So if a shape looks like this, or like a parallelogram, then what this tells you is this is representing one of the two things. It could be either it is input or it is output. So input and output, they both use the same shape, that is the parallelogram. In this case, it's like a rectangle, but with slanting edges. That is the parallelogram. So for now, just understand that when you see a flowchart, whenever you see such kind of a shape in a flowchart, then just know to say this is representing either input or output. In the example given here, you can tell that the first shape here where we're saying enter the radius, we want someone to enter a value. So in this case, this is input. So we have used the parallelogram shape because that is what is used to represent input in flowcharts. Again, here we are saying maybe someone entered the edge and then want to like display it somehow. So you say display edge. Displaying anything is like you want it to be seen on the screen. You want it to show somewhere on the screen, maybe on the calculator or on the computer itself, on the monitor. So as long as you're dealing with something being displayed, that is output. So again, that also makes use of the same shape, that is the parallelogram shape. So for now, what we've learned is that flowcharts makes use of shapes to represent various activities happening in pseudocode. And then we've also seen that in every shape that you're going to see, there will be some text inside each shape. That's why you can see even from the sample given here, there's some text, like inside these shapes. But for now, we've covered the fact that input and output are denoted or are shown in a flowchart by means of a parallelogram shape like this. So it's like a rectangle with slanting edges. So this is what represents input or output. Okay. Now, what else did we learn from our previous lesson on pseudocode? We also learned that one of the aspects of pseudocode is that you find some form of processing. Okay, like processing here, where some value is being computed. In flowcharts, how do we represent processing? In pseudocode, we represent processing by means of a rectangle, okay? And that's what you can see here. Now, if you remember very well, processing involves something like a value is being computed. So in this case, what are we doing? We're finding the area by multiplying A by B. So anything which has to do with a value being computed, that we can show it by means of a rectangle. Even if we are doing something like this, where we're saying pi is equal to 3.142, yes, we are still going to use the same shape here, the rectangle here. Okay, so assigning a value like this is a form of processing, okay, because you are taking a value, assigning it to something else. Okay, so this is going to be using a rectangle. So a rectangle is what is used to denote processing. Now make a difference between these. This is a parallelogram here with slanting edges, as you can see here, and then same thing with the output. But output and processing are different. Input is where something is being entered, and oftentimes you see words like enter this value, okay, or read this value. That means something is being entered. That is input. Output is anything where you say display this or show this on the screen. That's output. So any of those things always have the same shape, that is a parallelogram, as you can see here. But where we are processing, it's like now we are saying, we have these values. Can we now compute something? Okay. A good example of this is you have got 100 kwacha from Zamcash. They want 20% of this as interest. So if you are saying you're going to say this multiplied by 0.20, this will give us the payment. So you're going to pay this much. So if you are saying this is a process, we're going to show this in form of a rectangle. I mean something like this, okay? So be a rectangle to represent that. So anything that involves something being computed, like in this case, we're computing how much you pay. Here we're assigning the value of pi, just like here we're trying to find the area. Anything which has to do with anything being computed, that will always be denoted by the rectangle shape. Another shape that is used is the oval shape, like this, okay? Yeah, sometimes people write this like this, which I personally don't like. Okay, there will be people write this like this. Okay, and then they more like not this like this. Okay, it could be end or it could be start. So the oval shape is used to represent the start and end. So you have one start, okay, and you also have one end. So in a program or in a flowchart, you can never have two starts or two ends. No, it's always one start, one end. Okay, so normally a flowchart looks like this. Like at some point you are going to have the start, and then something happens here, then until where something is going to end. So there will always be some form of an ending, like that. So there's always one start and one end, and of course a number of things happening in between here, which could be anything to do with input, output, processing, and other things. So the shapes are straightforward. So this is input output, which is a rectangle. Processing, sorry, I mean input output parallelogram. Processing, rectangle. Start and end, oval shape. Okay, as simple as that. Okay, now another part of our flowcharts is the flow lines. So the arrows, there will always be lines in the flowchart. For example, it might start something like this, okay, and then you've got a start, and then you see a line like this. This tells you to say from the start, this arrow here tells you what is going to happen next. So if you find something like this here, okay, this tells you to say after this, the next thing to be done is whatever is here. So maybe this could be something like enter x, okay. This tells you to say after the start, the next thing to be done is to enter the value of x. How do you tell? Because of this arrow here. So the arrows in a flowchart on the flow lines, they indicate what is going to be the next step. So if we had a step like this, and then we had something like this, okay, and then we say y, for example, is equal to 2x, okay, or 2 multiplied by x. So this tells me to say after this here, what's going to come next? I need to look at this here. So this tells me to say the next action is this one here. So in a flowchart, there will always be lines like this, okay? Or there could be lines like this going up, or there could be lines sometimes going down. In most cases, they're going down. There are rare cases when a line goes up, but it's there. So these lines, okay, they tell you where the next action is in the process, okay, or in that program, so to speak. Okay, so what have we covered here so far? We've said in a flowchart there will always be start and end. So it will always have one start, one end. Then there will be some form of input output shown by means of a parallelogram, and there will be some form of processing that is indicated by means of a rectangle. And there will be obviously arrows connecting those shapes, which tells you to say from here the next thing you're going to do is this. Now, one of the very critical aspects of flowcharts is the diamond shape. Okay, the diamond shape. Remember what we discussed. Okay, if you have seen our video on pseudocode, we mentioned that pseudocode makes use of decisions where you say if this is this, then do that. Okay, if this is the case, then don't do this or do that. So this is where we find this shape very important. Okay, the diamond shape. So the diamond shape, this shape is used to represent some form of decision making. Okay, now this decision making is where you're asking, suppose I've got a value of x as say 18. I can ask myself a question like, is x less than 2? Okay, in this case, if x is 18 and x is less than 2, here I can say is x less than 2, I can say no. Okay, so the answer here is no, but sometimes it could be yes. For example, suppose x here was 1. In that case, I could have said, okay, if x is 1, is x less than 2? I could have said the answer is yes. So any condition like we said earlier on has got two possibilities. It's either it's a no, it's a yes, which could be true or false. So in this case, if x is 18 for sure, then we can say the action to take is that x is not less than 2. So here we go for this, but not this. But on a flowchart, if you want to indicate this scenario here on a flowchart, if you want to indicate this, what you do is there will be some form of an arrow. Obviously, nothing just comes from nowhere. There will be somewhere where this is coming from. So then you say, is x less than 2? What you do is, okay, if I want to begin from the top here, okay, where I say x is equal to 18. If you look at that, that is a process, it's not input. So you say, you put this, and then you say x is equal to 18. And the next thing we're going to do is x less than 2? As long as we ask in the question, is this equal to this? Is it less than this? Or that tells us to say that is a diamond shape. So at that point in time, we're going to put this diamond shape here. And what are we going to put inside here? We'll put the same question here. We're asking, is x less than 2? Okay. Now, what possible things can happen here? We're saying it could be no or it could be yes. So we should have two possibilities. That is why this shape, the diamond shape, it's used like this. It will always be here as a diamond shape. So one line will join it, and it will always have two lines leaving it. So there could be one line leaving here and one line leaving here. In our case, we can say let one line go this side and then let the other line go this side. Okay. What is going to be here? So I remember what we said. It could be no or it could be yes. So let's say here there's going to be a no. Here it's going to be a yes. So what we are going to put on this side here are going to be things which are going to be done in a case that where the value of x, where it is no, okay, where x is not less than 2. If x is not less than 2, what we are going to do can be put on this side here, okay, of the no. Then on the other side here, you can put things to be done in an event where the value of x for sure is less than 2. So if you notice here, it's kind of straightforward. Okay, it's always something like, okay, it's always something like, okay. Now let me just open up some something for more illustration here. Okay, so yeah. So generally speaking, what you are seeing is the diamond shape. Okay, the decision shape will always look like this. So some arrow comes here. Then here, what do you see here? There is some condition here being asked. Okay, is age less than 18? Okay, if age less than 18, two things can be done. This can be yes, or it could be a no. Okay, so it could be a no on this side. So here maybe a yes would mean doing things like tell the person to go home, that you can't admit them in a bar. Okay, or here it could be admit a person, okay, into a bar, or sell beer to a person because they are above 18. So this is a general idea. Okay, now here, if you notice here, I've done this. So these lines here, okay, these lines, it's either I can go from here like this, two of them, or you have two options. You can also do this. Okay, you can make them go this way or that way. So it could be a yes here and then the no this side. Okay, but it's the same thing at the end of the day. Okay, so that's the principle that you have to remember here. The flowchart or the diamond shape has got two possible outcomes: yes or no, or true or false, because it's a point where the decision has to be made on the flowchart. Okay. Now, let's look at some examples here. Let's look at some examples of how this works out. So I found these examples in some question papers. Yeah, courtesy of Z papers, zpapers.com. Okay. So here are some questions that you need to think about here. I'll come back to this one. Okay, let's look at this one here. So here we're given this to say the flowchart below shows the steps in calculating the volume of the solid given the area and height. Now, this first of all is a good example of a flowchart. So what does this tell us? Okay, from this we can go to say, oh, here we are starting. Okay, start. How do we tell the next step to follow after starting? We look at the arrow here. The arrow says come to this. Someone has to enter the value of A. So the best way you can visualize this is to say we've got the value of A. So if someone enters the value of A, we can picture to say, suppose someone enters maybe a value of 6. Okay. What do we do next? We don't have to guess where to go next. We'll look at the arrow here. The arrow says after someone enters the value of A, the next thing is it. So what did we say about this? So here there is a decision to be made. Okay. So is A less than 0? So how do you understand this? So you have to go back to what was A entered here. So if somebody entered A as 6, the question we should be asked here to say, is A less than 0? A is 6. Okay, in this case, we're not saying this is what it is, but we're just saying suppose somebody entered the value of A here. So what happens here depends on what was entered here. So we are saying suppose someone entered the value of 6. So is A less than 0? No. So at this point in time, this is not the case, but it will go this way. So if this is the case, then we won't even come this side. We might have come this side if maybe someone entered the value of -7 on A. They tell them enter the value of A, they put -7. Here when we would have come here and says is A, which is -7 less than 0, which is true. At that point in time, we could have said yes. So in that case, we couldn't have even have gone this side. We're just going to go this way and display this enter error message. Okay, A must be positive. Okay, so here now, let's proceed this way. So at this point, we are saying somebody entered the value of what? A as 6. So is A less than 0? No. So come this way. What do we do? Tell someone to say, according to this shape here, this shape tells me this is input. Okay. According even here, this was the input. Here, this one here, because it's saying error message, there's nothing like enter what or what. It simply means you are displaying something. So this is a case of output here. Okay. So here we tell someone enter the value of h. Again, what you can do is make an assumption. H, suppose you've got a variable for h here, then tell someone enter h. Then let's assume they enter the value of h as 10 as an example. Then what do you do next? This arrow here tells you where to go. So we are here now. We ask the question, is h, which is at this point we're assuming 10, is h less than 10, less than 0? Is 10 less than 0? No. So if it's a no, then obviously we won't go this side. Instead, we'll come this side. Okay. So we say V is equal to A times H. At this point in time, assume that you've got a value of V like this. Okay, we've got the value of V like this. So the moment you say V is equal to A times H, then you're saying go to A, get what is stored there, and go to H, get what is stored there. So it's 6 multiplied by 10, which is going to make it 50. Okay. So at this point in time, the value of V is computed. Remember what we mentioned here? What is happening here? Here we've got a value being computed. So what we have here is a computation. Okay. Hence, we're using the rectangle shape because we said The rectangle shape is what represents any form of computation or any form of processing. So the other way to understand the processing is to say something is happening to do with memory, some value in memory is being taken and multiplied here and there to obtain some new value, and that is what's happening. Hence we use the rectangle. It would be a mistake here to represent this by means of a shape like this. It would be a mistake because this is not input, so we can't use this. Okay, this is processing. Then here display v, we're displaying v. Since we're displaying, we learned that anything to do with displaying or output, that goes with a parallelogram shape. So input, output, they use the same shape. Okay, hence we have used this shape here. So simply put, after you find the value of v, then show to the user to say the value of which you have found is this, because somebody has to see it. So this is the whole point of this here. And then at the end of it, what do? We go and stop. So you see this, there's one step, one start, and then there's one end here. Okay, yeah. Now the question here says you have to write a corresponding pseudocode for this flowchart. How do you go about this? Okay, so the way you go about this is you don't have to beat about the bush, or you don't have to worry about anything. Converting this into a flowchart is one of the easiest things you can do. What you can do is begin by writing this start. So you can say start. Okay, and then what's the next step to be carried out? The next step to be carried out is this one, enter the value of a. So you tell someone, you write the same thing, you say enter a. Now notice here, when you say start, the next line will be, leave some space here like this. Don't begin from here, but rather begin from somewhere inside here. So I'm beginning from here. So enter a. So what's the next thing? Is a less than 0? You could do the same thing. Okay, let's say is a less than 0. Okay, so we know two things are possible here. It could be true, it could be false. So if this is true, what are you going to do? You simply say, if this is true, or if it's yes, what are you going to do? You simply go ahead and display this. Okay, you simply say display this. You display these words: error message, error message, a must be positive. Okay, so display this. Okay, so in a case, so you're asking yourself here is, but more preferable, instead of writing is here, you can also write it is as you say if. You say if a is less than 0. This is a more preferred way, okay, than this. Okay, so if a is less than 0, you do this. So what do you put here? So instead of putting the if here, I'm going to remove the is and put the if. Okay, so it's the same thing. So I'll say here, okay, I'll say if, okay, so if a is less than 0, so you say you display error message, a must be positive, and then you say else. Okay, what does else do? Else means in a case where a is not less than 0, this is what I'm going to do. So remember here what we had? Where the case, this could be yes, or it could be no, or it could be true or false. So if it's true, we'll carry out this. What if it is not? Then that is when we should come here. So as a way of showing to say, if this is not true, there is another action to be taken. I'm going to bring this here under the else, meaning if this is not true, what I'm going to do is this. So you say else, meaning if this is not the case, then I say else. Then I tell someone to say enter h. Okay, enter h. So the enter h, then what do I do next? According to the flow line, it says there's a condition coming next here. Okay, so you say is h less than 0. So I'll put a condition. I say if h is less than 0. If this was true, what am I going to do? Okay, so there are two things. If it's true, what am I going to do? If it's true, what am I going to do? I'll display this error message, h must be positive. So I'll come here and say, if this is true, I'll display this. Okay, I'll display this error message. Then I'll say h must be positive. Okay, h must be positive. Then if this is not, so I have two possibilities here. So if it's true, I'll do this. If not, I have to come here, right? So I say v is equal to a multiplied by a. That is simply a process. So what you do is, this should be done if this is not true. So you say else, you say v is equal to, now, so you put that process there. So v is equal to h multiplied by a. Okay. And what do you do next? You display the volume. You say display v. So at this point you say, just say display v like this, and that's where it ends. So since we had a start here, so we're going to have a corresponding end here. So we say this is where this is going to end. Okay, so this is how this can be worked on. Let's look at something close to that. Okay, so here is another diagram here. So here I'll be told, for this, let's convert this into a pseudocode. Okay, so how do we start here? Same thing, we do this, always begin with the start. Then what do I do next? So it says I have to enter the value of a and r. So I say enter a. Okay, I can say enter a comma r. I can put separate one if I want. Enter a, then I say enter r here. But since they have been entered like in no sequence, one after the other, I can say enter a, then enter the r. And what do I find next here? There's a diamond shape. Whenever you see this, then always think of a condition, and if. Okay, or is this the case? So you are going to say is. Okay, here you say if. Okay, so according to this, is some sign the absolute. If absolute r is less than 1, okay, yeah, so there are two possibilities. It could be true, it could be false. So if this is true, okay, if this is true, meaning we are going to come this side. Okay, so if this is true, what do we do? We're going to do this and this. Now this is the take part of flowchart. You've seen here there's one line here. If this is no, meaning if it's false, this line will come here and come here, and it comes and joins here. Okay, and then this one here, you see, this is where I say if this was true, this line will carry out this and that, and then they come and join here. So what this tells us is, if this is not true, then do what is here, and what is in this line here, there is nothing. So what this tells you is, if this condition is false, then don't do anything. Okay, if it's true, then you do this here. So if it's true, what are we going to do? We'll say we're going to compute the value of s as, say s is equal to, so you say it's a, okay, the value of a divided by 1 minus r, 1 minus r, like this. So this is s is equal to a divided by 1 minus r, and then after this, what do you do next? You say display sum to infinity. So you say display. So the sum to infinity here after this is this s here. So you say display s, okay, and that's it. So here, instead of putting the else here, because you see as it is here, if this was false, if this condition is false, there's nothing to do. So in this case, there's no need for us to put an else here, because even if you put the else here, there's nothing we're going to put here. We could have said else, then do ABC, okay? But what is going to come here? There's nothing here. So because there's nothing in this part here, okay? So in this case, there's no need, since there's nothing in this part, so there's no need for us to have anything here. So ultimately, there's no need for us to have anything here, okay? There's no need for us to have anything here. So I can remove this, okay? So we don't need to have also this. Okay, so this is where I can also put the end here. So I'll put the end here. So you can say after this you kind of end everything. Preferably it would be better if this also here, the start was moved a bit away, not in the same line as here, but more like here. Okay, yeah. So this is the best practice. You don't want, so what is being done between the start and the end is more like, comes a bit, inside here like this, like there's a space, yeah. So this is what this this flowchart must look like. Okay, then this one should even be simple because it's almost similar to what you saw above here. So how do we convert this into a flowchart? Okay, I mean into a pseudocode. So what we read this, okay, we say the first thing we're going to do is to do start. What do we see here? Enter x. This tells us it's input, so we'll also put it here. Enter x. Next thing is the condition is x less than 0. So you say if x is less than 0. Okay. If this is true, what are we going to do? If this is true, we say, so we follow this, the yes part. If this is true, what do we do? Print error x must be positive. So we say if this was less than 0, we would have said print, or we could have said display. You say error, then you say x must be positive, like this. Okay, so this is what you will do if x is less than 0. But what if it's not? Unlike the previous one, this one tells us to say if this condition is true, you do this. If it's false, you do this. So on the if, there's going to be an else here. There's going to be an else. Okay. What does the else do? It tells us what are we going to do if this condition here was false. So if this was false, what are we going to do? We'll come to the no part of this. So we'll come to the no part and we find that we have to find the value of r and then display r. So we'll simply say r is equal to r multiplied by, so r multiplied by, then you say cos x, okay, and then you say display r. Simply means you can say display this value of r. That is it, and the program ends. So while there was a start, there should also be a stop. So the final stop here can be put here like this. Okay. So you notice that there is this correspondence, like there is this lining between these, so you can see them, and then you can see how these are coming in the same line. Okay, that's the best practice of writing this pseudocode. Let me go back to the first part here. Okay. So this one has got a background. It says the diagram in the answer is an incomplete flowchart to calculate cos x from the triangle below. So it says complete the chart below by writing the appropriate statements in the symbols. Okay, so this one it kind of just requires you to know the rules of the rule of cosine. Okay, so I'm not sure if you know this rule. I won't focus on that because that's not the focus of this question. So you need to understand that if you have got this angle, let's call this angle as angle x here. Okay, then this side is x. Okay, and then this side is y and then z. So you have to understand that there is a rule which says if you want to find x, okay, if you want to find this x here, you can say x squared is equal to, then look at two sides which are besides x. So besides x there is z, there is y. So you can say this is equal to z squared plus y squared, and then you say minus, okay, minus 2. This is the formula here. So minus 2, what follows the 2 is the two sides. So this is x, this is side x. So the other sides of the triangle besides x is y, z, and the y. So minus 2 y, then z, okay, and then what you put next here is cos of this angle here x, okay, this angle here. It's simple. It's if the triangle is like this, okay, if this angle here was a and this, okay, if this angle here was a and this side was a and this was b and this was c, we would simply say it's you can put something like a squared is equal to the sides besides a are b squared plus c squared minus then 2bc and then multiplied by cos the angle itself a. That's the basic idea here. But anyway, when you have got this, if you want to find cos x, if you want to find this cos x, what do? You can take the other things on the left hand side. So what we are going to do is to bring this side and also bring this side. So this is going to come something like x squared. So if this z comes here, it becomes minus, so it will be minus z squared. If the y goes this side to the left, so if it jumps the equal sign, it becomes negative. It becomes minus y squared. Then you can say is equal to, so you're going to have a negative here, negative 2x y and then cos, okay, cos of x, okay, cos of angle x. So this is x, so xy. So if you want to find cos x, okay, because the question is focusing on finding cos x, not so. Yeah, so how do you find cos x? So since we want to find cos x, what we can do is we can divide this side by negative 2xy, and also divide this side also by negative 2xy. What does this tell us? Since here we are going to cancel this and that, so that we remain with cos x. So this is going to be cos x is equal to, so this is x squared minus z squared minus y squared divided by negative 2xy. So this is mistake here. Instead of this, we should have an x here like this. Okay. So this formula is what is going to give us a value of cos x. Now at this point in time, ask yourself, so for me to find cos x, what do I need to know? I need to know the value of x. I need to know the value of y. I also have to know the value of z. Yeah. Now notice that this x here, this is the angle here, angle x. So you need to know, and if you want to find the cos of this angle x, all you have to know is how long is this side x, how long is the side y, and how long is this side here z. So if someone enters these values here, if someone was to enter these, okay, then I can use this formula here to be able to find the value of cos x. What does this tell us? If we were to look at this flowchart here, it tells us to say someone must enter some values here. Someone enters some values here. Then using those, okay, someone can compute the value of cos x. This tells us to say what should be here is something like, here we tell someone enter x, y, z. Okay, that's what should be here. Then what should come here? Here you say you find cos x. So you say cos x is going to be equal to, so you get the value of x squared minus z squared minus y squared, this divided by the value of negative 2xy. Okay, so that is what should be there, and that afterwards you display the value of cos x. That completes this flowchart. Okay, so this is what I had for you on this. So I just want you to remember some simple things about what we've covered here. So if we have to summarize what we've covered here, we can say the following. You can say, if you look at any flowchart, you definitely are going to see a shape like this, which can denote start. Okay, you also be able to find a shape like this, which denotes end. Then obviously somewhere in between, you're gonna be able to see a shape like this. Okay, which tells you, oh, something is being entered. So this can have anything to do with displaying, or it may be the same shape here, but having to let someone say enter, tell someone to do something. Or you can may see a shape like this, which has to do with something being processed, okay, processing, or anything to do with computation, okay, computation, or anything to do with calculation. Okay, an example of this could be something where you say, okay, a is equal to l multiplied by b. Okay, that's a form of processing. So for that, you're going to use this shape, and then there always be something like this. Okay, yeah, where you see some line coming here, then there will be a possibility of this being yes, or there will be a possibility of this being a no. And what you have inside here is some kind of a question where you say, is x less than 0, something like this. So it could be yes, it could be no. So if it's yes, some things will be carried out here. Okay, so this is what will be done if it's yes, and then if it's no, some things will be done here. So there are two options to be carried out. So oftentimes, where this line goes and this line goes, they oftentimes come back and meet somewhere and proceed over here. And then how are these connected? There will always be some lines, there will always be lines like this, okay, showing you to say the next step to go to after this is this. But like we said, these shapes are never slanting like this. They shouldn't slant, but rather they should be, they should always be, sorry, they should be some kind of horizontal or vertical like this. Okay, so those are flow lines. They indicate what will be the next step. So that's the basic concept around flowchart and pseudocode. If you go through a number of questions and get the concept right, you find that it's one of those 3 marks that you can't afford to miss in the exam. So hope you found this helpful, and this is where I end this, and hope to see you on the next video.